Suppose I have a string that's about 7 meters long. Okay, so this axis here will be in meters. I've put my string along a coordinate system and I've marked 1 meter intervals. Okay, and then at time 0, t equals 0, I somehow, through some creative way, create two pulses on the string, one traveling to the right, one traveling to the left. Okay, now these pulses are not realizable on a real string, but I'm going to have very sharp corners on them just so we can practice with the principle of superposition. So let's suppose that the first pulse looks like this. Okay, so it rises from the equilibrium position at an angle for the first meter up to some maximum displacement, and then stays there for the next meter, and then comes straight back down. Again, you could not create that on a real string, but we want those sharp corners to be able to practice with the principle alone. Okay, and then that wave is traveling to the right at 1 meter per second. Okay, now over here, so that's 1, 2, 3, 4, 5, 6, 7. Over here at 5, I've got another pulse that is a triangle pulse that's traveling the other direction at 1 meter per second. Okay, and so it's like the leading edge of this one. It rises steadily from 0 to a maximum over 1 meter, but then decreases linearly back to 0 over the next meter. Okay, so the question I want to ask is, what will the wave look like, what will the string look like at 1 second, 2 seconds, and 3 seconds, or 1 second later, 2 seconds later, 3 seconds later? Okay, so the idea is to just think, where did they go, and redraw them individually, and then if they overlap, you add up their overlapping parts. So if they're traveling 1 meter per second towards each other, this one is going to travel 1 meter. That means its leading edge, the one close, the furthest to the right piece of this pulse, is going to travel from the 2 meter mark to the 3 meter mark. So it's going to be right here on this graph. And the trailing edge is going to be at the 1 meter mark. Okay, and then that corner is going to be at the 2 meter mark. Okay, so trailing edge gets to here, and it rises to the corner at 2 meters, going straight to the 3 meter mark and down. So that wave just moved over 1 meter because we're 1 second later, and it's moving 1 meter per second. Okay, well, what did this one do? So it was at the 1, 2, 3, 4, 5 meter mark, and so 1, 2, 3, 4, 5 meter mark. It was there. It's moving 1 meter per second to the left, so its leading edge is now at the 4 meter mark. Its peak is now at the 5 meter mark, and its trailing edge is at the 6 meter mark. So I have my triangle pulse there, like that. And they continue to move towards each other, or this one to the right, this one to the left, at 1 meter per second. So at 1 second, that's it. That's what the string will look like. It'll be flat, up, over, down, flat, up, down, over. Okay, that's what my string would look like according to this superposition, because they haven't occupied the same space in the material, the same piece of string, and so they're still just independent. But things get exciting when we get to 2 seconds. Okay, so at 2 seconds, they have now moved this one has moved 1 more meter, because 1 meter per second, to the right, and this one has moved 1 meter to the left. And so let's draw this one by itself. Trailing edge is now at 2. The leading edge is now at 4. So we have this for that pulse. This one, the leading edge, is now at 3, and the trailing edge is at 5. So we have that one. Okay. Now a portion of them is occupying the same space, the same part of the string. And so that piece of string, those molecules in that piece of string, are going to be moved as the sum of the two pieces, or the two pulses. Okay, so between 2 and 3, only this pulse occupies this piece of string. So this is the only thing that's going to happen between 2 and 3. Okay, Between 4 and 5, only this pulse occupies that piece of string. So this is going to be what that piece of string looks like. It's this plus 0, this is this one plus 0. But between 3 and 4, this pulse causes the string to do this, and this pulse causes the string to do this. And so the net result is adding these two together. So this is a constant value, let's call this 1, and we're adding this that goes from 0 to 1 to it. So it's going to be 1 plus 0 is 1, starts right there. This is 1 plus 1 is 2, and so we get, that should be a straight line, and we get 2, and it drops straight back down, because again, once we get to this point, from here on, only this piece of string matters. So yes, again, you may be sitting like, that's crazy, that could never happen. You're right. In real life, a string could not do that. But with these sharp edges, we're able to be very crisp and clear about how superposition is happening. So the string would be flat from here to here. It would rise steadily for 2 meters, all the way up to a double displacement, drop straight down half of that double displacement, and then decrease steadily over the next meter, and then be flat thereon. So this dark outline here is the shape of that string at 2 seconds. Okay, well at 3 seconds, let's just continue and see what it looks like. So that's kind of ugly looking, so I'm going to go back to this and say, okay, this one is now, in 3 seconds, has moved 2 units from this point. So the trailing edge is now at 3, and I can continue. So 1, 2, 3. Trailing edge for 1 meter, straight over and down. This one was at 4, and so now it's going to be at 2. Okay, so we get leading edge up to there for 1 meter and back down there for the next meter. And so this is what the two look like individually. So now we have to add them together. Okay, so like we did up there, between 2 and 3 meters, only this pulse is interacting with the material. So this is it. That's all we get for this piece, for this 1 meter. Between 4 and 5, only this one is interacting. So we're going to get flat here, straight down here. And then the outsides will just be there equal, because there's no pulse in those regions of space. So the next question is, what's happening in the middle? Well, if this one is falling from 1 to 0 over 1 meter, and this is rising from 1 to 0 over 1 meter, both of them linearly, that means they have the same but opposite slopes. And so if I am halfway in between, I have a half plus a half is 1. If I'm a quarter of the way in between, I have 3/4 plus a quarter is 1. If I'm 3/4 of the way through this gap, I have a quarter plus 3/4 is 1. And I can keep doing that, and the end result is a straight line across. So this, because they're equal and opposite slopes, they're going to add up to the same value across. And so now this piece of string looks like that all the way across. That is the principle of superposition. Now if we went one second further, this would now get to 1 and go from 1 to 3. This trailing edge would get to 4, and it would go from 4 to 6. And they would now not be interacting with each other. It'd look like this, only flip-flopped, with this one over here and this one right here. But that's an example of the principle of superposition. Now, you could ask the question, well, what if this was upside down? What if I had this instead? What would happen? Well, now this is causing the string to move downward, or giving it a negative displacement. This one is causing an upward or positive displacement. So when they start to interact, instead of adding together, they would subtract from. Okay, so let's do this one as an example. I'm going to draw another one. So if they're moving at the same speed, just this one's now upside down, I'd have, let's get my marks here. Okay, this one's still at 2, but it's down 1 and up to at 4. This one is as it was before, up, over, and down. So now the string goes from here to here, because again it occupies only this space. Over here it's like that. So we have our string so far. goes like this. And our goal is to figure out what's happening along this 1 meter piece of string. Okay, so right here I have 0 and I have -1. Okay, well 0 plus -1 is -1, so I have a dot right there. I'm sorry, it's getting a little low. Let me move this up. So I have a dot right there, this -1. Over here at this point I have 0 from this contribution to +1. Well, 0 plus +1 is +1, so I have a dot right there. Okay, which are the extremes? They should connect. Let's go to halfway in between. Halfway in between, I have +1/2 and -1/2, which means 0. Okay, I could continue doing that, and I would find that I get a straight line connecting that one to that one. Okay, so the string now looks like this, that, over, down, and across. That is what that string would look like. So instead of adding, I just subtracted whatever's below the string, thinking of it as negative.